Welcome to another unit in the workbook Statistics. This time I'm going to talk about t-tests for the coefficients of a linear regression. Well, first off, why are we actually conducting t-tests in this regard? Because, well, if we conduct a normal regression, we just calculate the coefficients. But we do not know whether those coefficients just result from random fluctuations or whether they actually describe a distinct existing, a significant impact of the respective variable. And that's what the t-tests actually are going to test, whether each of the different underlying independent variables has a significant impact on the dependent variable. And therefore, we're going to take the coefficients and we're going to use a t-test to test whether the coefficient is equal to 0 or significantly different from 0. Because if the coefficient is different from 0, this means that the underlying independent variable will have a significant impact on the dependent one. Well, how are we going to do this? It's first of what I just said. We're going to first off calculate the standard error of the regression coefficient. This can be done with the following formula, which just combines the standard error of the whole regression with the special part for the coefficient. In this case, we have this small epsilon here. What does this mean? Or the epsilon hat? That's actually for each observation the error we make with our estimation. So what we're going to take is our original value for the dependent one. Then we're going to subtract the value we get if we insert the independent variable in our estimated model. So in other words, if we subtract from the actual dependent value the estimated value. That's more or less the error we make in each observation. So that's the sum of all errors we make with our observation. Divided by, well, this looks quite familiar because this is more or less the same as with the standard, with the variance. So we have the error divided by the by the variance part. Well, this is quite familiar to what we might know in a different other context, because with the t-test we already have like an error divided by the standard deviation and so forth. So that's not really this different from conducting a normal t-test. That's just the standard error. Well, I now said standard error and not standard deviation for this test because this is, as we've seen, slightly different from what we understand as the standard deviation. But since it's similar to it, if we conduct a test, we even have to do less work than as if we were going to use the situation for the normal t-test. Because the test itself simply means we're going to take our coefficient and we just have to divide this by the standard error we just calculated. So we do not have to use the standard deviation here additionally. We also do not have to adjust for the number of observations. They are already included in this standard error as well. We also don't have to subtract any value here, any test value. Well, that's for the simple reason because the test value here is 0, and if I subtract 0, I will get exactly the same result. So here, test statistic is simply coefficient divided by standard error. Then we also need the number of observations, the number of variables, to actually find our reference statistic. Because the reference statistic in this case is number of observations minus number of variables minus 1. The minus 1 because we also, in almost all cases, have an intercept. Then we also have 1 minus 1/2 alpha. Well, After we calculated the test statistic, looked up the reference statistic, we're going to combine both of them and see which of them is actually the larger one. If the test statistic is larger, then the t-test tells us our regression coefficient is significantly different from 0, so the underlying variable has a significant impact on the dependent one. Well, that's everything there is on the t-test for coefficients, so I hope you enjoyed it. I say goodbye and see you next time.